And we're back. This is a Middle Perch live on the internet. I am MTK on the MIC, and the MIC is picking up all kinds of weird noises right now. In addition to the track Unlooped. All music here is produced on Music Maker Jam, an app for the Android. It's out of Germany, and it's pretty cool. As Article 13 kicks in Europe, and there's more concern about people being censored if their content is not original, then one way around it is to get one of these apps and just make your own music. I've made about 30 tracks now, and I'm just going to let them run underneath the show. I feel like that's a safe way to proceed. And it also isn't dry, you know? I'm not into dry microphones. It strikes me as not very sensible. How's our light? The light looks pretty bright. The preview screen is not accurate. I've noticed. So. At least we get a decent picture of what's going on. It was quite cold last night, so I had the scarf on, which is why the cap is flipping about. This is a live stream. It takes place every once in a while on the internet. I am your host, MTK. We talk about a wide variety of things, and this past week what I did was I threw up a couple of reviews, book reviews, onto the net. Reviews of books I had written in 2017 and 18. They were just, laying around on a website, so I thought, hey, I'm going to read these aloud so that people who want to just listen to them can, you know. And in doing that, I also sent them to whichever artists or authors had a Twitter handle. And one of them, Jennifer Egan, the author of Manhattan Beach, most recently, and of a visit to the Goon Squad, is it? Or from the Goon Squad? Which, in 2011, I believe, won the Pulitzer Prize for fiction. I have not read that yet, but I did a review of Manhattan Beach, and I sent it to her. And guess what? She wrote back to me on Twitter. It was cool. It was amazing. And in the same day that I received that note from Jennifer Egan, tweet reply, if you will, I was like, wow, look at that, a Pulitzer Prize winner on my phone here. An email came at the exact same time, and guess who it was from? Professor Wilson, who has no less than 2 Pulitzer Prizes for his book on the ants in the 1970s, and the other one I think is in the 90s, on nature, perhaps. And I had written him saying, I'm reading Consilience aloud, and I didn't really ask anyone. And so I probably, this is what I sent him a note saying that. And he wrote back, Dear Mr. Karthik, I am pleased to have you use my... Hang on one second. Why does it take so long to open? Dear Mr. Karthik, I am pleased to have you use my work in your teachings. Warmly, Edward O. Wilson. Look at that. From Harvard University Museum of Comparative Zoology, 26 Oxford Street, Cambridge, Mass. So in the space of just 12 hours, 2 Pulitzer Prize winners wrote to me. That was pretty cool. And I'm glad that Professor Wilson said it was cool to continue reading Consilience, which we are going to do. Chapter 5, we're going to begin today. Ariadne's Thread. It's interesting because the setup has been, I think, pretty fascinating. The natural sciences, first the Enlightenment, the natural sciences, and a discussion of the sort of division of knowledge, and now Ariadne's thread. And I'm quite excited to read that today. But I wanted to add another book review as well. This is Midnight Mass by Paul Bowles. I think I'm going to leave it run because I don't like it dry. I mean, it's not too loud, is it? Book review, Midnight Mass by Paul Bowles. I believed I had read all the fiction Paul Bowles ever published in these 18 years since his death, now 19 years since his death. The discovery last week of the short story collection Midnight Mass with the familiar Black Sparrow paperback binding, earthy tan with green and purple block print, was thus a very emotional experience for me. Immediately, I was flooded by memories and thoughts of the man I considered my favorite author from the time I discovered him in 1987, the summer I got my first tattoo, until his death at the end of the last century. Instantly, too, in that powerful way that great literature connects us with the world we are in, I remembered myself experiencing his works, where I was, the effect it had upon me, the empowerment and awe I felt after finishing one of his short stories or novels. Blown away. Paul Bowles was a huge influence on me as a writer and thinker. He was one of the most powerful allies in my struggle with immigration to the United States and in philosophical discourse in Europe. That he wrote from the subconscious, as described by his wife Jane, was the most romantic and amazing concept to me when I was young. And I longed to be able to do that, not to understand it, but to do it. The utter irrationality of the Western project, the neoliberal insanity we have all endured so long, was exposed by Bowles, and then swiftly and violently shattered by the reality of life among the desert people of North Africa. In other works, a slow and seemingly disconnected series of events between locals in a village would be described with such lucidity and simplicity that the differences in thinking between East and West were made suddenly crystalline in the end. It hits you like a koan. The collision of culture was total, and instead of Coca-Cola and the Golden Arches mowing down the village, the puny, minuscule Westerners melted away in the heat of the Saharan sun, driven mad. Midnight Mass is the last collection of Bowles' short stories published by Black Sparrow and features at its center the elegant, drifting, rootless novella Here to Learn, a gorgeous story about a girl from North Africa who just keeps moving, buoyed by her beauty, her wit, and her ability to learn quickly how to negotiate the West. The collection starts with the titular story, Midnight Mass, one of Bowles' incredible parties, the Nazarenes careening around in their expatriated stupor of drinking, carousing, and complaining, the locals bursting with romance only to become suddenly something else, the change of face. There are stories about the locals and their fantastic, sometimes circuitous logic and its culmination in a kind of basic justice. There are tales about the utter undoing of our perception of a shared understanding of this world. At the Krungtep Plaza is an amazing story, set as the U.S. president is due to pass through a certain North African village. The machinations behind the scenes and the conflicts between locals, expats, and the security teams are expertly related, culminating in a wild effusion of emotions that I can only describe as angst against the way things are now. It's all just so great. I miss Paul Bowles. Paul Bowles, 18 years after he died, was the best writer I read last year. So that's the review of Midnight Mass. We'll add that as a clip as well.
world 7 times. I drop dimes to write rhymes. I never do cry. Did you see me? Them's mimes. When I was a kid, I made chimes. Common half for an octave, fifth for a third. Pythagorean, you heard? Yeah, all the time.
A reference to the wind chimes I used to make as a kid. When playing with this software, it's fun to kind of mic things as well. And in fact, I might write some lyrics and raps, but that was just a simple rhyme for fun. And it ended up being cool because Pythagorean theorem is exactly what is involved there in pitches and tones. Or Pythagorean math, we should say. Let us get into consilience. It's chapter 5, Ariadne's thread. For that, we are going to go drive. Okay, so stop, please. Thank you. Okay, we are reading Consilience, the Unity of Knowledge. This is chapter 5, Ariadne's thread. With the aid of the scientific method, whoops, it's not how to start with a pop like that. Chapter 5, Ariadne's thread. With the aid of the scientific method, we have gained an encompassing view of the physical world far beyond the dreams of earlier generations. The great adventure is now beginning to turn inward, toward ourselves. In the last several decades, the natural sciences have expanded to reach the borders of the social sciences and humanities. There, the principle of consilient explanation guiding the advance must undergo its severest test. The physical sciences have been relatively easy. The social sciences and humanities will be the ultimate challenge. This uncertain conjunction of the disciplines has mythic elements that would have pleased the ancient Greeks. Treacherous road, heroic journey, secret instructions that lead us home. The elements have been assembled into many narratives over the centuries. Among them is the story of the Cretan labyrinth, which can also serve as a metaphor for consilience. Into the heart of the Cretan labyrinth walks Theseus, Heracles-like champion of Athens. Through each corridor, past uncounted twists and turns, he unravels a ball of thread given him by Ariadne, love-struck daughter of Crete's king Minos. Somewhere in the hidden passages, he meets the Minotaur, the cannibal half-man, half-bull to whom 7 youths and maidens are sacrificed each year as Athens' tribute to Crete. Theseus kills the Minotaur with his bare hands. Then, following Ariadne's thread, he retraces his steps through and out of the labyrinth. The labyrinth, its likely origin a prehistoric conflict between Crete and Attica, is a fitting mythic image of the uncharted material world in which humanity was born, and which it forever struggles to understand. Consilience among the branches of learning is the Ariadne's thread needed to traverse it. Theseus is humanity, the Minotaur our own dangerous irrationality. Near the entrance of the labyrinth of empirical knowledge is physics, comprising one gallery, then a few branching galleries that all searchers undertaking the journey must follow. In the deep interior is a nebula of pathways through the social sciences, humanities, art, and religion. If the thread of connecting causal explanations has been well laid, I don't know why I'm trying to do 2 things at once. It's because I can't see the images. Sorry. Forgive me for this brief. If the thread of connecting causal explanations has been well laid, it is nonetheless possible to follow any pathway quickly in reverse, back through the behavioral sciences to biology, chemistry, and finally physics. With time, we discover that the labyrinth has a troubling peculiarity that makes its mastery, complete mastery, impossible. While there is an entrance, more or less, there's no center, only an immense number of endpoints deep within the maze. In tracking the thread backward from effect to cause, assuming we have enough knowledge to do so, we can begin with only one endpoint. The labyrinth of the real world is thus a Borgesian maze of almost infinite possibility. We can never map it all, never discover and explain everything. But we can hope to travel through the known parts swiftly, from the specific back to the general, and in resonance with the human spirit, we can go on tracing pathways forever. We can connect threads into broadening webs of explanation, because we have been given the torch and the ball of thread. There is another defining character of consilience. It is far easier to go backward through the branching corridors than to go forward. After segments of explanation have been laid one at a time, one level of organization to the next, to many endpoints, say geological formations or species of butterflies, we can choose any thread and reasonably expect to follow it through the branching points of causation all the way back to the laws of physics. But the opposite journey from physics to endpoints is extremely problematic. As the distance away from physics increases, the options allowed by the antecedent disciplines increase exponentially. Each branching point of causal explanation multiplies the forward-bound threads. Biology is almost unimaginably more complex than physics, and the arts equivalently more complex than biology. To stay on course all the way seems impossible, and worse, we cannot know before departure whether the complete journey we have imagined even exists. The accelerating growth of forward-bound complexity, from entrance to endpoints, is illustrated with textbook clarity by cell biology. Researchers have used the reductionist principles of physics and chemistry to explain cellular structure and activity in admirably brilliant detail, with no discernible room left for rival approaches. They expect in time to explain everything about any particular kind of cell chosen for study, reducing it organelle by organelle, and finally reassembling it holistically, thus traveling toward the labyrinth entrance and simplicity. But they nourish faint hope of predicting, as opposed to explaining and reconstructing retrodictively, the character of any complete cell from physics and chemistry, hence traveling away from the labyrinth entrance toward rising complexity. To recite one of the mantras of science, the explanations of the physical sciences are necessary, but not sufficient. There is too much idiosyncrasy in the arrangement of a particular cell's nucleus and other organelles, as well as the molecules composing them, and too much complexity in the cell's constantly shifting chemical exchanges with the environment to accomplish such a conceptual traverse. And beyond these particularities awaits the still hidden history of the prescriptive DNA, stretched across countless generations. Again, this is in 1998. Put briefly, the questions of interest are how the cell is put together and what was the evolutionary history that led to its prescription. In order to proceed, biologists are compelled first to describe complexity in the cell, then break it down. To go the other way is conceivable, but the biologists all agree it will be forbiddingly difficult. So first to describe complexity, then break it down. To dissect a phenomenon into its elements, in this case cell into organelles and molecules, is consilience by reduction. To reconstitute it, and especially to predict with knowledge gained by reduction how nature assembled it in the first place, is consilience by synthesis. That is the two-step procedure by which natural scientists generally work. Top-down across 2 or 3 levels of organization at a time by analysis, then bottom-up across the same levels by synthesis. The procedure can be simply illustrated with a modest example from my own research. Ants alert one another to danger at a great distance. When a worker ant is jostled, pinned to the ground, or otherwise threatened, nestmates up to several inches away somehow sense her distress and rush to her aid. Her, I say, because all workers are female. Alarm can be communicated by sight, but only rarely, since confrontations usually occur in the dark, and in any case, many kinds of ants are blind. The signal can also be transmitted by sound. Agitated workers make squeaking noises by rubbing their waists against a rear segment of their bodies, or else repeatedly pump their bodies up and down to strike the ground. But again, sound is used only by some species, and then only on special occasions. Knowing these facts in the 1950s as a beginning entomologist, I speculated that the key alarm signals are chemical. The substances are what researchers in those days called chemical releasers, and today are known as pheromones. To test my idea, I collected colonies of red harvester ants and a few other species whose natural history I knew well. Then I installed them in artificial nests not much different from a child's ant farm. With the aid of a dissecting microscope and watchmaker's forceps, I dissected freshly killed workers to obtain organs that might contain alarm pheromones. I crushed each one of these barely visible white gobbets of tissue onto the sharpened tips of applicator sticks and presented them in turn to resting groups of workers. In that way, I learned that at least two of the glands are active. One opens at the base of the mandibles and the other next to the anus. The ants were galvanized by the substances released from the glands. They raced back and forth in whirligig loops around the applicator sticks, pausing only occasionally to examine and snap at the crushed tissue. I had pinpointed the origin of the pheromones. But what were they? I enlisted the help of Fred Regnier, a chemist of like age just starting his own career. He was expert in the skills most needed at that time to advance the study of ant communication, the analysis of extremely small organic samples. Using the latest technique of the day, gas chromatography and mass spectrometry, Regnier identified the active substances as a medley of simple compounds called alkanes and terpenoids. He then obtained samples of identical compounds that had been synthesized in the laboratory, guaranteeing their purity. Presenting minute quantities to the ant colonies, we obtained the same responses I had observed in my first experiments and confirmed that the glandular components Regnier had identified were the alarm pheromones. This information was the first step to the understanding of broader and more basic phenomena. I next enlisted the help of William Bossert, a young mathematician. We were all young in those days. Young scientists have the best ideas and, more important, the most time. Intrigued by the novelty of the problem as well as by the small stipend I offered him, he agreed to construct physical models of the diffusion of the pheromones. We knew that chemicals evaporate from the gland openings. The molecules closest to the openings are dense enough to be smelled by the ants. The three-dimensional domain within which this occurs we called the active space. The geometrical form of the active space can be predicted from knowledge of the physical properties of the molecules and confirmed by the time required for the expanding cloud of molecules to alert the ants. We used both the models and experiments to measure the rate of spread of the molecules and the sensitivity of the ants to them, and established with reasonable certainty that workers released evaporated pheromones in order to communicate. The steps in reasoning we followed are universal in scientific research. They follow from the consilience of the disciplines established by generations of earlier scientists. To solve the problem of alarm communication in ants, we employed reduction, working our way down from one level of specific organization, namely the organism, to a more general level, the molecule. We tried to explain a phenomenon in biology with physics and chemistry. Luckily, our ideas succeeded this time. The same approach to pheromone research continued to be rewarded in the decades to follow. Scores of biologists working independently established that ants organize their colonies with many chemical systems like those used to transmit alarm. Their bodies, we discovered, are walking batteries of glands filled with semiotic compounds. When ants dispense their pheromones, singly or in combination and in varying amounts, they say to other ants, in effect, danger, come quickly, or danger, disperse, or food, follow me, or there is a better nest site, follow me, or I am a nestmate, not an alien, or I am a larva. And on through a repertoire of 10 to 20 messages with the number differing according to caste, such as soldier or miner worker, and species. So pervasive and powerful are these codes of taste and smell that altogether they bind ant colonies into a single operational unit. As a result, each colony can be viewed as a superorganism, a congeries of conventional organisms acting like a single and much larger organism. The colony is a primitive semiotic web that crudely resembles a nerve net, a 100-mouthed hydra writ large. Touch one ant, one strand of the net, and the displacement spreads out to engage the communal intelligence. We had crossed 4 levels: superorganism to glands and sense organs to molecules. Was it possible then to turn around and travel in the opposite direction, predicting the outcome without advanced knowledge of the biology of the ants? Yes, at least in the form of a few broad principles. From the theory of natural selection, molecules serving as pheromones can be expected to possess certain properties that allow efficient manufacture and transmission. Adding in principles of organic chemistry, we concluded that the molecules will likely contain 5 to 20 carbon atoms and have molecular weights between 80 and 300. Molecules acting as alarm pheromones, in particular, will usually be on the light side. They will be produced in comparatively large quantities, for example, millionths rather than billionths of a gram in each ant. And the responding workers will be less sensitive to them than to most other kinds of pheromones. The combination of traits allows quick transmission, followed by a rapid fade out of the signal after the danger passes. In contrast, trail substances, which are followed by the ants from nest to food and back, can be predicted to consist of molecules with the opposite qualities. Their traits allow long duration of the signal, as well as ensuring privacy of transmission. This privacy prevents predators from locking onto the signals and hunting down the senders. In war, and nature is a battlefield, make no mistake, one needs secret codes. These predictions, or educated guesses if you prefer, qualify as consilience by synthesis. With some puzzling exceptions, they have been confirmed, but biologists cannot predict from physics and chemistry alone the exact structure of the pheromone molecules or the identity of the glands that manufacture them. For that matter, in advance of experiments, they cannot stipulate whether a given signal is used or not used by a particular species of ant. To attain that level of accuracy, to travel all the way from physics and chemistry near the entrance of the labyrinth to an end point in the social life of ants, we need detailed collateral knowledge of the evolutionary history of the species and of the environment in which it lives. Predictive synthesis, in short, is formidably difficult. On the other hand, I believe that explanation in the opposite direction, by reduction, can in some instances be achieved across all levels of organization, and hence all branches of learning. As a demonstration, I will now attempt to trace a magician's dream all the way down to an atom. Serpents are in the magician's dream, transfigured from real-life snakes. I have not placed them there capriciously. They belong as the wild creatures most frequently conjured around the world in dreams and drug-induced hallucinations. Coming with ease to Zulu and Manhattanite alike, serpents are powerful images of human fantasy, flesh and blood snakes transformed into flickering images of the subconscious mind. There, depending on the culture and experience of the individual dreamer, they are conjured variously as predators, menacing demons, guardians of a hidden world, oracles, spirits of the dead, and gods. The slithering bodies and lethal strikes of real snakes make them ideal for magic. Their images evoke blends of emotion that fall on a triangular gradient defined by 3 points of fear, revulsion, and reverential awe. Where the real snake frightens, the dream serpent transfixes. In the dreamer's paralytic state of sleep, the serpent cannot be escaped. Snakes are abundant and diverse in the rainforests of western Amazonia. Serpents, their dream equivalents, figure prominently in the cultures of the Amerindian and Mestizo inhabitants. Shamans preside over the taking of hallucinogenic drugs and interpret the meaning of the serpents and other apparitions that subsequently emerge. The Jivaro of Ecuador use maicua, the juice from the green bark of a member of the nightshade family, Datura arborea. Warriors drink it to summon arutams, ancestors living in the spirit world. If the seeker is fortunate, a spirit emerges from the depths of the forest, often in the form of two giant anacondas, which in real life is the species Eunectes murinus, heaviest of the world's snakes, big enough to kill a human being. The dream serpents roll toward him, entwined in combat. When they come within 20 or 30 feet, the Jivaro must run forward and touch them. Otherwise, they will explode like dynamite and disappear. Like dynamite in quotes. Still need a cough button. After receiving his vision, the Jivaro must tell no one, or else the spell will end. That night he sleeps on the bank of the nearest river, and as he dreams, the Arutam returns to him as an old man. It says, quote, "I am your ancestor. Just as I have lived a long time, so will you. Just as I have killed many times, so will you." Close quote. The apparition then disappears, and as it does, its soul enters the body of the dreamer. The Jivaro rises at dawn with an enhanced feeling of bravery and grace in bearing. His new demeanor is noted by others in the scattered households of the local Jivaro community. If he wishes, he can don the bird bone shoulder ornament that symbolizes Arutam soul power. In the old days, he would have been considered fit to serve as a warrior on headhunting expeditions. 500 miles southeast in Amazonian Peru lives Pablo Amaringo, mestizo shaman and artist. Drawing on the traditions of his Amerindian forebears, the Kokama and Quechua speakers of the Amazonas and Cajamarca, Amaringo conjures visions and depicts them in paintings. His drug of choice, widely used in communities of the Rio Ucayali region, is ayahuasca, extracted from the jungle vine Banisteriopsis. His dreams are populated with serpents in most of their Amazonian cultural roles, mounts of gods, forest spirits, ambush predators of animals and people, impregnators of women, landlords of lakes and forests, and sometimes the sinuous ayahuasca vine itself transmuted into animal form. In the rich local Shipibo tradition, followed by Amaringo in his paintings, the serpents, as well as other real and supernatural beings, are decorated with intricate geometric designs in primary colors. The paintings also share the Shipibo horror vacui. Every available space is crowded with detail. The style fits the Amazon region, which teems with life of stupendous variety. Amaringo's subjects are loosely eclectic. Spirits and conjurers and fantastical animals from ancient Amerindian myths are thrown together with contemporary Peruvians and industrial artifacts. Ships and airplanes pass by. Even flying saucers hover above the rainforest canopy. The images, surreal and disturbing, freed from normal sensory input, are incarnate emotions in search of theater and narrative. Their craziness illustrates the principle that during trances and dreaming, any metaphor serves, and any fragment of memory able to slip into the unguarded mind becomes part of the story. The sacred plants, which have been analyzed by chemists, are no longer mysterious. Their juices are laced with neuromodulators that in large oral doses produce a state of excitation, delirium, and vision. The primary effects are often followed by narcosis and dreaming of similar kind. In the Jivaros datura, they are the structurally similar alkaloids atropine and scopolamine. In Banisteriopsis of the mestizos, they include beta-carbolines, to which the shamans usually add dimethyltryptamine from another plant species. The substances are psychotropic, stimulating a flurry of images intense enough to break through the controlled processes of ordinary conscious thought. They alter the brain in the same manner as the natural neuromodulator molecules that regulate normal dreaming. The difference is that under their influence, people enter a semi-comatose trance in which dreaming, uncontrolled and often vivid and urgent, is no longer confined to sleep. It is tempting to patronize the spiritual searches of the Amazonian vegetalistas, just as it is easy to dismiss the counterculture's innocent faith in drug-soaked gurus and sorcerers during the 1960s and 70s. Outside of a few cults, few people today believe in the late drug guru Timothy Leary, or even remember Carlos Castaneda and his once famous The Teachings of Don Juan. Yet it would be a mistake to underestimate the importance of such visions. They tell us something important about biology and human nature. For millennia, the use of hallucinogens to enhance inner awareness has been widespread through the cultures of the world. Natural sleep and drug-induced dreams have long been viewed in Western civilization as a portal to the divine. They appear at pivotal moments in both the Old and New Testaments. We learn from Matthew 1:20, for example, that as Joseph pondered Mary's pregnancy, the conception of Jesus, quote, "Behold, an angel of the Lord appeared to him in a dream," close quote, to reveal the Holy Spirit as progenitor. Joseph's witness established one of the two essential pillars of Christian belief, the other being the disciples' account of the resurrection, also dreamlike. Emanuel Swedenborg, the 18th century scientist and theologian, whose followers founded the Church of the New Jerusalem, believed that dreams contain secrets of the divine. God does not restrict his word to holy scripture. If the sacred code cannot be found under the microscope, as the Swedish savant discovered to his disappointment, it might yet be forthcoming in the scenarios of the dream world. Swedenborg recommended irregular hours and sleep deprivation as a means of inducing sharper and more frequent images. At least he had his physiology right. I suspect that he would have enjoyed a stiff dose of ayahuasca. Consider then the dreams of a magician, a sorcerer, a shaman. They are more than just unique productions of a single mind. They exhibit qualities general to the human species. The art of Pablo Amaringo is worthy of analysis in the manner of the natural sciences. His paintings are a test case of consilience, an arresting fragment of culture that might be explained and thereby given added meaning at the next biological level down in complexity from artistic inspiration. It is the habit of scientists to look for elements available as entry points for such analysis. To this end, I have chosen two elements from Amaringo's paintings that present themselves for convenient explanation: the dreamscape as a whole and the serpents that conspicuously populate it. Mysticism and science meet in dreams. Freud, aware of the conjunction, composed a hypothesis to explain their meaning. He said that our dreams are disguises for unconscious wishes. When we sleep, the ego releases its grip on the id, which is the embodiment of instinct, and our most primitive fears and desires then escape into the conscious mind. They are not, however, experienced in raw form. Like characters in a bad Victorian novel, they are altered by the mind's censor into symbols so as not to disrupt sleep. The average person cannot expect to read their meaning accurately upon awakening. He must turn, Freud argued, to a psychoanalyst who will guide him through free association in order to decipher the codes. As the translations are made, the connections of the symbols to childhood experience become clear. If the revelation unfolds correctly, the patient enjoys an easing of neuroses and other psychological disturbances that stem from his repressed memories. Freud's conception of the unconscious, by focusing attention on hidden irrational processes of the brain, was a fundamental contribution to culture. It became a wellspring of ideas flowing from psychology into the humanities. But it is mostly wrong. Freud's fatal error was his abiding reluctance to test his own theories, to stand them up against competing explanations, then revise them to accommodate controverting facts. He also suffered from the luck of the draw. The actors of his drama, id, ego, and superego, and the roles they played in suppression and transference, might have evolved smoothly into the elements of a modern scientific theory had he guessed their basic nature correctly. Darwin's theory of natural selection prospered that way, even though the great naturalist had no idea of particulate heredity carried by genes. Only later did modern genetics verify his insight concerning the evolutionary process. In dreams, Freud was faced with a far more complex and intractable set of elements than genes, and to put it as kindly as possible, he guessed wrong. The competing and more modern hypothesis of the basic nature of dreaming is the activation synthesis model of biology, as created during the past 2 decades by J. Allen Hobson of Harvard Medical School and other researchers. It pieces together our deepening knowledge of the actual cellular and molecular events that occur in the brain during dreaming. In brief, dreaming is a kind of insanity, a rush of visions largely unconnected to reality, emotion charged, and symbol drenched, arbitrary in content and potentially infinite in variety. Dreaming is very likely a side effect of the reorganization and editing of information in the memory banks of the brain. It is not, as Freud envisioned, the result of savage emotions and hidden memories that slip past the brain's censor. The facts behind the activation synthesis hypothesis can be interpreted as follows. During sleep, when almost all sensory input ceases, the conscious brain is activated internally by impulses originating in the brain stem. It scrambles to perform its usual function, which is to create images that move through coherent narratives. But lacking moment-to-moment input of sensory information, including stimuli generated by body motion, it remains unconnected to external reality. Therefore, it does the best it can. It creates fantasy. The conscious brain, regaining control upon awakening and with all its sensory and motor inputs restored, reviews the fantasy and tries to give it a rational explanation. The explanation fails, and as a result, dream interpretation itself becomes a kind of fantasy. That is the reason psychoanalytic theories relating to dreaming, as well as parallel supernatural interpretations arising in myth and religion, are at one and the same time emotionally convincing and factually incorrect. The molecular basis of dreaming is understood in part. Sleep descends upon the brain. When chemical nerve cell transmitters of a certain kind, amines, such as norepinephrine and serotonin, decline in amount. Simultaneously, a transmitter of a second kind, acetylcholine, rises in amount. But both wash the junctions of nerve cells specialized to be sensitive to them. The two kinds of neurotransmitters exist in a dynamic balance. The amines waken the brain and mediate its control of the sensory systems and voluntary muscles. Acetylcholine shuts these organs down. As acetylcholine gains ascendancy, the activities of the conscious brain are reduced. So are other functions of the body, except for circulation, respiration, digestion, and remarkably, movement of the eyeballs. The voluntary muscles of the body are paralyzed during sleep. Temperature regulation is also diminished. That is why it can be dangerous to fall asleep while the body is cold. In a normal nocturnal cycle, sleep is at first deep and dreamless. Then, at intervals consuming overall about 25% of the total sleep period, it turns shallow. During the shallow periods, the sleeper is more easily awakened. His eyes move erratically in their sockets, the condition called rapid eye movement, or REM. The conscious brain stirs and dreams, but remains sealed off from external stimuli. Dreaming is triggered when acetylcholine nerve cells in the brainstem begin to fire wildly, initiating what are called PGO waves. The electrical membrane activity, still mediated by acetylcholine at the nerve junctions, moves from the pons, the P of PGO, a bulbous mass of nerve centers located at the top of the brainstem, upward to the lower center of the brain mass, where it enters the geniculate nuclei, that's the G, of the thalamus, which are major switching centers in the visual neuronal pathways. The PGO waves then pass on to the occipital cortex, that's the O in PGO, at the rear of the brain, where integration of visual information takes place. Because the pons is also a principal control station for motor activity when the brain is awake, the signals it passes through the PGO system falsely report to the cortex that the body is in motion. But of course, the body is immobile. In fact, it is paralyzed. What the visual brain does then is to hallucinate. It pulls images and stories out of the memory banks and integrates them in response to the waves arriving from the pons. Unconstrained by information from the outside world, deprived of context and continuity in real space and time, the brain hastily constructs images that are often phantasmagoric and engaged in events that are impossible. We fly through the air, swim in the deep sea, walk on a distant planet, converse with a long dead parent. People, wild animals, and nameless apparitions come and go. Some constitute the materialization of our emotions triggered by the PGO surges, so that from dream to dream our mood is variously calm, fear-struck, angry, erotic, maudlin, humorous, lyrical, but most of the time just anxious. There seems to be no limit to the combinatorial power of the dreaming brain, and whatever we see, we believe, at least while sleeping. It rarely occurs to us to doubt even the most bizarre events into which we have been involuntarily thrust. Someone has defined insanity as an inability to choose among false alternatives. In dreams, we are insane. We wander across our limitless dreamscapes as madmen. Strong stimuli can break through the sensory barrier. If they do not wake us, they are fitted into the dream story. Let real thunder roll into our bedroom from lightning a mile away. To take one of endless possible responses, our dream switches to a bank robbery, a gun is fired, we are shot. No, another person is shot, has fallen, but no, again, we realize it is us, displaced to someone else's body. Oddly, we feel no pain. Then the scene changes. We were walking down a long corridor, lost, anxious to get home. Another shot is fired. This time we come awake, tense, to lie in the real world and listen to real thunder roll in from the approaching storm outside. In dreams, we seldom experience the physical discomforts of pain, nausea, thirst, or hunger. A few people suffer apnea, a temporary halt in breathing, which may be turned into visions of suffocation or drowning. There is no smell or taste in dreams. The channels of these sensory circuits are shut down by the acetylcholine wash of the sleeping brain. Unless we wake soon afterward, we remember no details of any kind. 95 to 99% of dreams are forgotten completely. A small minority of persons believe, erroneously, that they do not dream at all. This amazing amnesia is apparently due to the low concentration of amine transmitters, which are needed to convert short-term memories into longer ones. The next section is what is the function of dreaming, and we'll pick that up next time. This is chapter 5 of Consilience. Ariadne's Thread is the title of the chapter. This is part 1.